In the previous lesson, we implemented support for searching and filtering inside of our REST API, but another very common requirement is being able to sort the responses to a GET request based on a query parameter that contains the columns that you want to sort by. There are a couple of ways of how you could approach implementing this inside of our REST API, and I'm going to focus on the approach that I think is the most flexible. We're going to introduce another query parameter called sort, and this query parameter contains a comma-separated list of values that represent the columns that we want to sort on. Now, what's interesting to note here is that the values in the sort query parameter refer to the properties that are exposed on the resource representation. This is going to be our data transfer object that we are returning from the API. Now, under the hood, this could map to some different concepts inside of the actual database. So we have to take care of properly translating the query parameters that reach our API into something that can be translated into a correct SQL query that we can execute on the database. If our resources support nested objects, like the frequency object that has a type and a times per period value, then we should probably also support sorting by these nested values, and our API has to accommodate this. You can also specify the sort direction, which can be either ascending or descending, and if you omit the sort direction, then we are going to assume the ascending search order. It would also be smart to sort our records with some default value when nothing is specified, and the most natural solution here is using the primary key of your underlying table. Now let's jump into the code and see how we're going to implement support for sorting inside of our REST API. I will continue expanding the example that I have inside of the habits controller. We already implemented support for searching and filtering, and we are mapping our query parameters into the habits query parameters object. So let's go ahead and introduce another argument here that's going to represent my search query parameter. It's going to be a nullable string, and I'll just call it sort. I will leave the specific naming convention that you want to use up to you, and I'm going to use something that is widely recognized and used, like the sort query parameter. Now let's go back to our controller and see what we can do with the sort query parameter. Remember that we are sorting based on the properties of the habit DTO, but we have to translate this into our underlying entity, which is the habit type, and this requires us to get a little creative. So let's say I want to sort based on the name column. I can write an order by statement and sort based on the name. Now I can also sort by multiple columns, and if I want to do this, I can chain another call to the order by statement by saying then by, and for example, let's say I want to sort on the description. By default, this will be the ascending sort order, and if I want to update it, I can call order by descending or then by descending and so on. Now if you take a look at the argument here, you will see that this is in fact just an expression on our habit type that returns a string that represents the actual value that I'm sorting by. Now in the most general sense, this is going to return an object. So let's see if I can define an expression in place that's going to represent my order by statement. So we need a function on the habit type that returns an object, and let's call it order by, and you can already see I'm getting a code completion. So where I'm going with this is defining a switch expression on the query sort value, and based on the provided value, I'm going to define the actual sort that I want to support inside of my API. So let's say I have a mapping defined like this. Then I can take my order by expression and pass it in as the argument to the order by method. Let's omit the then by call, and with this we have implemented some very basic support for sorting inside of our API. Now if we want to be able to chain multiple order by statements, then this is going to become a bit more complicated and we'll have to resort to a different solution. But for now, let's just test this out and see if this is working as expected. Inside of Postman, let's send a GET request to our API with a new query parameter. We're going to call this sort, and I'll specify the value of description. Let's send this request, and we're going to land on the breakpoint inside of the habits controller. What I'm interested in is the switch expression that I have here, and you can see that the sort value matches one of the cases that I defined, which is going to give me back an expression on the habit type, which selects the description property for sorting. So then I'm going to apply this to my query, and you can see that we get back the habits, and if I press continue, we will get back the response inside of Postman. If I take a quick look at the query that was sent to my database, you can see that we have an order by statement and we are sorting in ascending order based on the habit description column. So our simple implementation seems to be working as expected. However, this has several drawbacks. First, defining a switch expression like this for every sorting operation that you want to do is pretty cumbersome. Secondly, we aren't even supporting different sort directions like ascending and descending, and how are we going to support sorting based on multiple fields in the same request? So I'm going to scrap the initial implementation, which was just for demonstration purposes, and let's go back to the drawing board. What if we could specify an order by statement by simply passing in the sort parameter? Now, imagine if this was a structured string, like name ascending, and then description descending, and end date descending, for example. And then this is something that could be translated into a SQL query. Well, EF Core out of the box doesn't support this, but there's a very cool NuGet package that we're going to install, which is going to allow us to do this. So let me install this NuGet package. I'm going to look for dynamic link, and the library I'm going to install is called System Link Dynamic Core. Let's go ahead and install the latest version, and let me close this down. And in order to be able to execute a query like this by specifying a string, I need to reference the system link dynamic namespace. So let's add it here with a using statement. And now you can see that this is no longer complaining because we now have the respective extension method. So the next thing I want to do is to generalize the support for sorting so that we can make it reusable inside of our application. I'll create another folder that's going to contain the implementation for this, and I will nest it inside of the services folder. This is going to contain some general purpose services that we will be adding in the upcoming lessons, and we're going to start by adding support for sorting. Now, the first thing I want to do is a small helper class that will allow me to define my sort mapping from the sort field that I specify inside of my API request into the respective property on my entity. So let's define a record that contains the sort field value, the property name which I am mapping to, and we may also want to add support for reversing the sort order if the column that we are sorting on represents some computed value. A good example of this is an age value that you expose on the client, which maps to a date of birth, date, time inside of your database. Now let's say if someone's age is 30, then it means that they were born in 1995 based on the date and time when I'm recording this video, which is 2025. Now if I wanted to sort based on the largest age, which would be age descending, how would we achieve the same value by translating this sort into the date of birth column? Well, we'd have to reverse it and sort by date of birth ascending. We want the lowest date of birth to show up first, which is going to translate to the highest age. So this is why we have the reverse property inside of the sort mapping. Then what we need to do is to define a set of sort mappings for our DTOs and our entities. And I will create a simple helper type that's going to help me encapsulate this. And I'll call this a sort mapping definition. This is just going to be the marker interface. The next thing I need to define is an actual implementation of this. I'll call it a sort mapping definition. And I will make this a generic type so that I can define my mapping from the sort object into the destination object. Let's also implement the isort mapping definition interface. And all I want to have inside is an array of sort mapping objects, and let's call it mappings. So what is the idea behind these abstractions? I want to be able to define my mappings from a given sort field into the destination property on my entity, and I want to be able to do this when I'm writing the code so that I can use these definitions at runtime to properly generate my order by statements and even perform input validation on the sort parameters. Now, one more thing I want to do is to make the reverse value optional, and by default is going to be false. Now let's go ahead and define a sort mapping definition. I'll give you an example of this for my habit DTO, and I'll define this inside of the habit mappings class. Let me add the definition, and then let's discuss what we have here. I'm creating a static read-only instance of a sort mapping definition from the habit DTO into my habit entity. This just contains an array of mappings, and I'm mapping the properties from the DTO object into my entity. Now in this example, it's mostly a one-to-one mapping. However, I am using the nameOf operator so that my definition is refactor proof if I want to change the name of these properties in the future for any reason. For complex properties, I'm respecting the name of the nested values, so it requires a bit more code to define the proper mapping. And then what am I going to do with this? Well, the idea is to register this with dependency injection. So I'll go to my program file, and let's scroll to right after we introduce OpenTelemetry. And here I'll start registering my services. So what I can do is add a singleton service. The abstraction will be an iSort mapping definition, which is my marker interface, and then the implementation will be a sort mapping definition of a habit DTO and a habit, and then I can just provide the implementation by specifying my habit mappings and the static sort mapping definition that I already created. So we're slowly putting the pieces in place. Let me drop this down, and then let's put our attention back to the sorting services. What I need next is an abstraction that is going to contain the sort mapping definitions and is going to allow me to find a concrete definition for my given source and destination types. I'm going to call this the sort mapping provider, and it's going to have a dependency which is going to be an IEnumerable of iSort mapping definitions. I'll give it a name of sort mapping definitions, and then let's disregard the code completions that keep popping up. And I want to expose one method here, which returns an array of sort mapping objects, and I'll call it getMappings. Now this will be a generic method where I'll specify the source and the destination type. And the idea here is to be able to perform the of type operator on the sort mapping definitions that we have. So if I say of type and then I specify source mapping definition of t source and t destination, and assuming that I registered only implementations of this type with dependency injection, which we have done, then I can say first or default and get an instance of this type. So let's call this the sort mapping definition. So if this isn't null, then I can just return the mappings. But if it is null, then we can decide what we want to do. Let's say I throw an invalid operation exception. I can write a custom message like the mapping from type of t source, and then we can access the name into type of t destination, and then let's also access the name isn't defined. So let's convert the concatenation into interpolation, and then this will be an exception message that I can throw. If it's not null, then we're going to return the concrete mappings. Let's register this service with dependency injection. I'll register it as a transient service because it's a lightweight service. So let me add the sort mapping provider. And now we need one more component for all of this to fall in place, and this is an extension method on the iQueryable interface is going to allow us to take the query parameter containing a comma-separated list of values representing our fields and convert that into an order by statement that I can execute using the dynamic link library that I just installed. So let's go ahead and define this extension method next. I'll make it an internal and static class. Let's call it queryable extensions, and I'll